I wanted to talk about feedback loops in a typical amplifier. Maybe not a super typical amplifier. This is a 0.01 Tiger schematic I'm mostly referring to here, but I'm going to go general at the end here. What's odd about this schematic is it actually has two feedback loops, and that's why I went through all the trouble of diagramming this out, decoding it, so to speak. I really like the way he draws his schematics, but at the very end he did some strange things to the resistors. Makes it kind of hard to follow versus the way I drew it, and the way it more typically would be drawn shows your output, straight through. Of course, he's working in the crowbar transistors and everything else, so it made sense drafting-wise, I'm sure. And also the way this other line, there's a couple things in here that are confusing. This and this are the same line, basically, this line and this line, but you don't see it that way unless you really look at it. So it's a little bit of a devil to... So I kind of simplified it a little bit, and because I'm curious exactly what's going on with the feedback in this amp. Okay, so crowbar is not shown. Bias circuit I kind of half drew. Now this amplifier, the man who designed it, his name was Daniel Myers of Southwest Technical Products Corporation. Very brilliant engineer. He had a whole product line of stuff, and he actually ended up, in the end of his company, mostly going over to making computers. Although parts for these kits remained available, I got repair parts and my last two Tigers fairly late when he already had his computers out. Maybe at the very end he was only doing computers. His computer thing, like all computers, well, it would have probably died like most of them died, the little upstarts in the early days. Only a few survived, but he died, at some point, and so... The company really didn't carry through after that. So anyway, he considered this a triple, and maybe that's why he justified in his head putting a separate feedback loop for this triple, setting the gain of this triple so it acts like a one amplifier module. And if you ever looked at like RF modules and stuff, the amps, they don't show all this detail, they just show this whole amplifier as one big amplifier, or just like you'd see an IC chip, basically. So he considered this output a triple, and he's setting the gain of this triple with this feedback loop. So it does act like a triple. And then you've got the, the 4 transistors for the input, real typical deal. And then you've got your global feedback, which I've drawn in red. So I drew this output current and output feedback in orange. And I drew in red this global feedback. And this is more complicated the way he's adjusted things here. You see 60 PF here, a 1K, a 2.2K. If I got these right, I don't have the parts list for this amp handy. I got to find the manual. I really want to get this project hot railed out of here. I got two of these that are never finished. I need some parts. I'm probably going to order a lot of different resistors too, because I can get better resistors than they had back then, really. Mostly in tolerance. I can go 1% or 2%. And the 5% that are in there in my old amps really do vary 5%. They're not like all to the one side or something like that, like you'd expect. I got some real bad mismatches in one of those amps. They're within 5%, but they're like opposite ends of the spectrum. So anyway, upgrading resistors might happen before I build this PC up. So that's kind of a project. And I know parts are missing, and I'm missing documentation, although my friend can help me out with that, my friend Kurt. Anyways, there it is, 2 different feedback loops. Now, another item of interest is the Zobel, some people will call it, on the output here. And, okay, call it a Zobel or call it whatever you want. A Zobel is an equalization device, and it's not a simple equalization device. It's one that is designed in such a way that it can be put in a transmission line and not cause a reflection. So an equalizer, like in an RF amplifier, you have these input equalizer and you've got an interstage equalizer sometimes. Those equalizers are that type. They're Zobels, where they have higher loss than a simple LC cutoff would do for you. You'd have a lot less loss if you made the traditional, simple RC circuit to high pass or low pass. So you'd have less loss, but you'd also have a big impedance mismatch. So a Zobel is made, it'll be a lossier circuit and a more complicated circuit, but it'll have a better match, basically, on both sides of the line, on both ends of the circuit. So in this case, we got a resistor with a coil wrapped over it. Call it a Zobel if you wish. I'd like to hear better explanations about what they're for, but it's basically a stability item as far as I've heard about. And I thought this was part of it too, but it isn't. It actually is a separate feedback loop. So I'm glad I drew this out, because I thought this was all part of the output Zobel. But, it is, but it isn't. It's more complicated than that, because this is the feedback loop, and you've got a slight RC thing here happening. Very interesting. I'm glad I drew it out, because I never fully understood what was going on right here. And the way the circuit's drawn over here is a little bit opaque. So it was worth drawing out.